Hey guys, welcome back. As you can see, I have a little helper today with Marvel. If he starts going crazy and barking at cars during the video, I'm so sorry. He's just been nuts today. Anyway, we're going to be talking about possible outcomes for compound events and then also using tables to find a complete list of the sample space. All right, let's get started.
Let's start by talking about sample space. So sample space, it's not complicated. All it is a list of all the possible outcomes of a certain event. So let's say you're rolling a dice. Your sample space would be 1, 2, 3, 4, 5, and 6. It's just all the numbers on that dice. Then if you were to flip a coin, you could either get a heads or a tails. And that is your sample space for both of those. Now, if we are doing compound events, say you were looking for the sample space of a dice and a coin, this would be all possible combinations of the two. And we can find the number that would be inside of that sample space by using the fundamental counting principle. That's just a big, long, fancy word for saying the sample space of event A and event B is going to be equal to the number of things inside of A and the number of things inside of B. If we were talking about these two instances, we would have 6 inside of dice and 2 inside of coin. So we would do 6 times 2. So our sample of dice and coin would actually have 12 items inside. And I think we actually have that specific example on our work page. Now, filling out a table, it's not too complicated. We're going to treat it like a Punnett square, just like you've done in science. So go ahead and put on your science cap. And I know some of y'all are like, oh, no, but I promise it's not going to be complicated. All right, that being said, we need to remember that what is up must come down and what is left must go right. That being said, in this little example I have here of math rocks, if we have an M, the M will fall into all the boxes below it, and the A will fall into all the boxes below it, and so on. Then our R, which is on the left, will move all the way to the right and be in every single one of those boxes. And then bam, you have a complete list of your sample space right in the inside. And as you can see, we would have 12 items in our sample space. All right. Now that we've gone over all of that, let's move into our page. As you can see, I've highlighted a couple things here on the top of our paper, but I'm going to go ahead and start in the for instance section. If you would like to pause now and take note on what I've highlighted, that would be great. So in this section, I have completely worked through the problem for you. The question reads, what are the outcomes for flipping a coin and spinning a spinner with red, green, and blue sections? All right. So we need to first identify the two things that are happening within our events. We are told we are flipping a coin and spinning a spinner. Okay? That is how we know that our two events are coin and spinner. The next thing we need to do is think about how many possible outcomes there are for each thing. Obviously, with a coin, we have either heads or tails. That is where we get our two outcomes. For the spinner, we can look at the question and it lists that we have red, green, and blue sections, which gives us a total of 3 options on our spinner. Therefore, using our fundamental counting principle, we do 2 times 3 to get a total of 6 possible outcomes. Then I created a table here. Across the top, I listed the outcomes of our spinner. We have red, green, and blue. For our coin, we had heads and tails. Now, remember we're going to treat this like a Punnett square. So whatever is up must come down. So with our red is going to drop into both these boxes downward. Then our green will drop into both these boxes. And our blue will drop into these boxes. Now, looking at what's on the left, it must go right. Therefore, heads must go into these 3 boxes. This is telling us that we could flip a head and spin red, or we could flip heads and spin green, or we could flip heads and spin blue. All 3 of those are different combinations. We do the same with our tails. It's left, so it must go right. This gives us a total of 6 different options for flipping a coin and spinning our spinner, meaning our sample space has a total of 6 different items inside of it, and this is a list of those items. Moving on to the Let's Practice section, here I've only given you the question and I have not filled out the table for you, and we're going to do that together. The first question reads, what are the outcomes for flipping a coin and rolling a dice? Remember, we're going to start by looking at the 2 things that are happening. We are flipping a coin and rolling a dice. So we need to know the number of outcomes for our coin and the number of outcomes for our dice. As we set up here, you have heads or tails on your coin. Then on a dice, you know you have 6 different numbers. Then we just multiply the 2. 2 times 6 gives us a total of 12 outcomes. Now what are they? We'll have to fill in our table to find out. Across the top, I would fill in the numbers that are on your dice, which is 1 through 6. Down the side, fill in your options for flipping a coin, which is heads and tails. To fill in our table, what is up must come down, so our 1 drops into both these boxes, 2 goes into both these, 3 goes into both these, and so on. Then what is left must go right, meaning heads goes in this box all the way over. And then tails goes in all of them across the bottom. And this gives us a completed table of our sample space. And we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items inside, which is exactly what we should have gotten. Looking at number 2, what are the outcomes for rolling 2 dice? I have 2 dice here just for you to see. Okay, if we're rolling 2 dice, that means the 2 events that are happening are dice and dice. As we stated up here, each dice is going to have 6 different options for rolling. So our total number of outcomes for question 2 is 6 times 6, which equals 36. For filling in this table, let's go ahead and fill in 1 through 6 right here. We're also going to do it down the sides. Some questions will ask you to fill in a sums table, which then you would add the 2, but this is just asking for the possible outcomes, which means all we have to do is if the 1 must go down, this 2 must fall down, and so on. All right, I didn't want y'all to have to watch me write in all those numbers. Also, I want you to remember what is left must go right. So again, our 1 is going to go all the way across. The same with
Alright.
R2. Here we go. And as you can see inside, we have 36 different combinations, which is exactly what we thought we found.
All right, guys, as you can see, my buddy's still here, and I hope you are too. If you have any more questions, please let me know so I can help you out. I'll see you back tomorrow.